Problem 5, the angles of elevation of a balloon from 2 points A and B on level ground are 24 degrees and 47 degrees. And what happens is a lot of times when you read these questions, you'll start to draw your diagram. So I'm going to do that. I have my balloon up in the air, and then I have 2 points on the ground, A and B, and it says the angles of elevation, so those are the angles along the bottom, are 24 degrees and 47 degrees. So this kind of looks like what you have going on. It says points A and B are 8.4 miles apart. So the distance between A and B, so this distance right here, is 8.4. But here's the problem sometimes, and this is sometimes why you have to kind of erase your picture and start over. The balloon is between the points. Here I drew my balloon kind of off to the side. So I'm going to have to erase this picture and redraw it. Okay, so now I have the diagram where I have the balloon is up in the air. Okay, the angles of elevation from 2 points A and B are 24 degrees and 47 degrees. Points A and B are 8.4 miles apart in the same vertical plane. Approximate the nearest tenth of a mile the height of the balloon. So I got to try to figure out what this height here is going to be. And always what you're solving for, you look for a triangle that balloon is in. That X is in, excuse me. So here, X is either in this red triangle or X is in this green triangle. So you have to try to pick one of the triangles and work with it and try to go about solving for X. So maybe I'll pick my red triangle. I know this is point A, this is 24 degrees, this is X. Do I know anything else about this triangle? Well, I'm trying to find the height, so I know it's a right triangle, just like my green triangle is a right triangle. But do I know anything else about this red right triangle? And the answer is no. I know the entire bottom from A to B is 8.4, but I don't know what that is. What I'm going to do is this. I'm going to go about finding the hypotenuse of this red triangle. I'm going to call that Y. Once I know what Y is, then I can use SOHCAHTOA in this red right triangle because I have an angle. The angle is 24 degrees. I know X is opposite that angle. And then once I know Y, once I know it, is going to be the hypotenuse. And then I'll be able to find X, since I'm given the opposite and the hypotenuse, I'll be able to use sine. But I'm going to have to try to figure out what this Y is first. And to do that, I'm going to have to use a different triangle. That side Y is in this big triangle. So what I'm going to do is I'm going to use this big triangle, maybe I'll call that my blue triangle, to go about solving for Y. So here in that big triangle, here's what I know. I know points A and B are 8.4 miles apart. I know that's 47 degrees. I know that's 24 degrees. And that's Y. So what I did was I just simply redrew the big blue triangle, and I'm going to use that triangle to go about solving for Y. Maybe I'll call this top point where the balloon is point C. And let me go through my checklist. Is this going to be an example of SOHCAHTOA? Do we have a 90-degree angle? Well, I have two of the angles, 24 and 47. I can add them up and then subtract that from 180. And when I do that, I believe this top angle is 109. So that's not 90 degrees, so I can't use SOHCAHTOA. Next, I'm going to go about solving for y by seeing if I can use the law of sines. To use the law of sines, you need to be given a matching set of side angles. And here I think I have that. Since I found the top angle, angle C, and since I know the bottom side is side C, I can use the law of sines to figure out what y is. Y in my diagram is the side opposite angle B, so that's little b. So I'm going to write little b over the sine of angle B. That equals now my c's. Little c over the sine of big C. So here I have little b, which is y, over the sine of angle B, so the sine of 47. That equals little c, that's 8.4, over the sine of angle C, that's the sine of 109. Again, what am I trying to do? I'm trying to solve for y, so that way I'll have the hypotenuse of that right triangle, and then I'll be able to go about solving for x, the height of the balloon. So let me go back to this triangle. Here I'm using the law of sines, so I'm going to cross multiply. I have y times the sine of 109. That equals 8.4 times the sine of 47. And here I'm going to divide both sides by the sine of 109. So here that side y, I'm going to calculate by doing on my calculator 8.4 times the sine of 47 over the sine of 109. So here you're going to have y equals 6.5. So that 6.5 is going to be that left-hand side of the big triangle. But that 6.5 is also going to be the hypotenuse of that red triangle. So now what I'm going to do is I'm going to go and use SOHCAHTOA on that red triangle, because here my angle was 24. I'm solving for x, the height of the balloon, and now I know 6.5 is the hypotenuse. So again, since I have opposite and hypotenuse, I'm going to be using sine. The sine of an angle equals opposite over hypotenuse. So here I'm going to have the sine of the angle was 24. That equals the opposite, which is x, over the hypotenuse, which we said was 6.5. And here, since my x is in the numerator, I'm going to put the sine of 24 over 1 and cross multiply. Remember, if x would have been in the denominator, we would have used that whole switcheroo rule. But here, I'm just going to cross multiply. So I have 1 times x, which is x. That equals 6.5 times the sine of 24. So if you do this on your calculator, 6.5 times the sine of 24, you'll get the height of this balloon. So here the height of the balloon is going to be 2.6. I think they gave you everything in terms of miles. So here it's going to be 2.6 miles. And that's our final answer here. Number 6, after a storm, a tree is leaning from vertical 3 degrees. So here I'm going to have the ground. I'm going to have this tree, and as opposed to standing straight up, it's leaning 3 degrees from the vertical. So if I kind of draw a line going straight up, it's going 3 degrees to one direction. So I kind of drew it to the right. It says we have a house. So we'll put the house, I guess, over here. A person standing on the front porch notices the angle of elevation to the top of the tree. So this angle right here is 40. If the house is 60 feet from the base of the tree, well, here's the bottom of the tree, here's the house. So this distance here is going to be 60 feet. how tall is the tree? So the tree is kind of leaning a little bit to the right, so that's going to be my x. So if we look at this diagram, we have our triangle, and they give you this 3 degrees. And how is that going to help you? Well, from the vertical, so from going straight up and down, and you kind of compare that to the ground, here you're going to have a right angle. Well, a right angle is 90 degrees. But since 3 degrees are taken away, I know the angle that the tree is making with the ground is 87 degrees. So here's my triangle, which I'll kind of now copy over. I have one angle, this angle here is 87, this angle here is 40. I'm trying to find x, and I know the bottom, the base, is going to be 60. So here if I throw some letters in the problem so I can communicate, if I go through my checklist, first I look to use SOHCAHTOA, meaning I'm looking for a 90-degree angle. Here I have 2 of the angles, so it's always good once you're given 2 angles to add them up and subtract it from 180 to figure out what the third angle is. A lot of times that third angle turns out to be helpful. So here the third angle turns out to be 53 degrees, so we're not using SOHCAHTOA because there's no 90-degree angle. Next we look to see if we can use the law of sines. The law of sines means you need to be given a matching set of side angles. And here we have that. Here we have angle A is 53 degrees, and here we have side A is going to be 60. So that's a check. I'm going to be using the law of sines, and here my x is opposite angle C, so I'm going to write little c over the sine of angle C. That equals now my matching set, my a's, little a over the sine of angle A. So I'm going to substitute in little c, that's what I'm solving for, that's x, over the sine of angle C. Well, here the angle for C is 40 degrees, so x over the sine of 40. That equals little a, so that's going to be 60 over the sine of angle A, so that's going to be the sine of that 53 degrees. Here I'm using the law of sines, so I'm going to cross multiply. So I have x times the sine of 53. That equals 60 times the sine of 40. And I'll solve for x by dividing both sides by the sine of 53. So to figure out the height of that leaning tree, on your calculator you have to do 60 times the sine of 40 degrees over the sine of 53 degrees. So here this tree is going to be 48.3, and I think this question gave you feet, but 48.3. Problem 7 we are not responsible for yet because we haven't talked about the area formula yet. Number 8. A ship in the bay is 18 miles from one lighthouse and 30 miles from another. So you have this ship and you have these 2 lighthouses, and it says the ship is 18 miles from one lighthouse, 30 miles from another. What is the distance between the lighthouses if the measure of the angle formed by the line of sight to the lighthouse is 130 degrees? Well, here we have the ship, and the ship is looking at these 2 lighthouses, and the angle formed by the lines of sight is 130 degrees. So this is the diagram that you needed for this problem 8. And here as we go through our checklist, SOHCAHTOA, do we have a 90-degree angle? And the answer is no, we have a 130-degree angle. Are we going to be using the law of sines? Are we given a matching set of side angles? Here, I don't believe that's the case. I have angle S, but I don't have side S. Here I have the two lighthouses, and maybe I'll call this point A, call this point B. Here I have side A, but not angle A. Here I have, this is point B, side B, but not angle B. So here I'm not given a matching set, so I'm not using the law of sines. Here, to use the law of cosines, there's two forms. Number one is if you're given two sides and the angle between. If that's the case, then you're going to be using the law of cosines that says a squared equals b squared plus c squared minus 2bc times the cosine of a. That's the law of cosines if you're finding a side. You could also use the law of cosines if you're given all three sides and you have to find an angle. If that's the case, then you'll use the law of cosines that says the cosine A equals b squared plus c squared minus a squared over 2bc. This is an example of number one. Here you're given two sides and the angle in between. Here you're given the 18 and the 30, and you have to find this side because you have the angle in between. So here I'm going to be using this version of the law of cosines. Here in my diagram I'm finding angle S. So I'm going to write S squared equals, I called this A and B, so A squared plus B squared minus 2AB times the cosine of S. Remember, when you use this version of the law of cosines, the outsides have to match. Here I'm finding side S, so I have to use angle S. So here I have S squared equals A squared, so that's 30 squared, plus B squared, that's 18 squared, minus 2 times A times B, 2 times 30 times 18, times the cosine of angle S, so the cosine of 130 degrees. So here I'm going to enter this entire side into my calculator, and since this is S squared, I'll then take the square root of that answer. So here it looks like that distance between the lighthouses is going to be 43.8.